Our guest today is Lukas Biewald. Lukas is one of the world-leading and earliest AI entrepreneurs. In fact, his first company, Crowdflower, was founded in 2007, many years before the modern deep learning era of AI took off. In 2019, Crowdflower, by then renamed into Figure 8, was sold to Appen for $300 million. Right before that, in 2018, Lukas founded a new machine learning developer tools company, Weights & Biases, which is still heads up today. In fact, I'm lucky enough to be a small investor in his company. In between, Lukas also spent some time at OpenAI, where we actually had a good amount of overlap. Lukas, so great to have you here with us. Welcome to the show.
Thank you so much.
Well, Lukas, before diving into today's conversation, I would like to thank our podcast sponsors, Index Ventures, and actually Weights & Biases, your company.
Nice.
Index Ventures is a venture capital firm that invests in exceptional entrepreneurs across all stages, from seed to IPO. With offices in San Francisco, New York, and London, the firm backs founders across a variety of verticals, including AI, SaaS, fintech, security, gaming, and consumer. On a personal note, Index is an investor in Covariant, and I couldn't recommend them any higher. Weights & Biases is a ML ops platform that helps you train better models faster with experiment tracking, model and dataset versioning, and model management. They're used by OpenAI, NVIDIA, and almost every lab releasing a large model. In fact, many, if not all, of my students at Berkeley and colleagues at Covariant are big users of your product, Lukas, Weights & Biases. So, Lukas, we overlapped at Stanford, which you might maybe remember.
Of course I remember.
We overlapped at OpenAI, a bit more recent. I've been at AI community events that you have hosted. You've been at AI community events that I hosted. I've been on your Gradient Descent podcast. So glad to finally have you on my podcast here, The Robot Brains. Thanks so much for making the time.
Thank you. It's an honor.
So let's dive right in. What is Weights & Biases?
Well, I think we just heard the official line in the what do you call it, the advertisement in the beginning. But I'll say from my perspective, Weights & Biases from the very beginning has been all about building a platform to support the life cycle of machine learning in the real world. So helping people from, the data collection to the model building to the deployment into production, and really doing the things that ML developers don't want to do. Like kind of we always look for the kind of like tough part that shouldn't be tough, and the stuff that isn't fun, and taking it out of the hands of the people doing the really exciting model building. And I think our perspective has always been from the very beginning that we wanted to build stuff that we actually wanted to use. Me and my co-founders were ML engineers, and we looked at the products out there in the market at the time, and it all seemed like very products were decided by kind of like a kind of top-down corporate like thinking, and we wanted to make things that's just like we would be proud to give to our friends and have them use. And so we started with experiment tracking, which is what we're really well known for. And, since then we've added hyperparameter optimization and dataset versioning and model registry. And we kind of keep adding things as our users and customers request them.
I like this notion. You're excited to do the things that everybody else finds painful and hopes not to have to do, hopes magically it gets done by somebody else. Imagine you must have a field day going out, talking to practitioners. I mean, everybody has their complaints.
Yeah.
Are there conversations you think back at from the early days of Weights & Biases where you say, okay, well, these conversations really told me this is what we need to be doing?
Oh yeah, there's so many. When we first started, we thought maybe experiment tracking would be too small of a thing. And I think one of the things that really gave us confidence is when we put it in the hands of OpenAI. And I remember Wojciech telling me, at first I didn't think this would be very useful. And it was actually really hard to get him to use it. And then he said, I can't believe how much more useful this is than I thought. And that really gave us a lot of confidence. And then I remember another conversation with Hamel, who is at GitHub, and he was like, Lukas, your tool is really useful, but the UI is so ugly that I actually don't want to use it. Like, I'm thinking of even going to a competitor because their UI is so awful. And that really inspired us to kind of clean up the UI. And I think that actually might be the thing that really led to our growth, which is funny because I think engineers, especially ML engineers, wouldn't think that they're so motivated by like a nice looking UI. But I think at the end of the day, we're all human beings and we want to use products that are delightful.
I mean, the one use case, of course, is the developers, researchers, ML engineers using it. But from where I sit as a professor, as a chief scientist at Covariant, essentially not running the experiments myself, it's also very interesting to see my collaborators, they'll pull up graphs from weights and biases to show what's going on, what's working, what's not working. So from my perspective, actually, the UI is the only thing I personally experience, and it's nice that it's, well taken care of.
Well, if you have any feedback, we're always open to it. Most of our good ideas have come from guys like you.
Now, well, I'll keep that in mind. Next time I get some results presented. You started a company now, 4 or 5 years ago. By the way, the name is really, weights and biases, such a clever name, obviously. Now, when you started the company, you wanted to help people track their experiments. And that's still a really important use case today. Is it still the biggest use case?
Oh, for sure. Yeah.
Where do you see that go with other use cases popping up, new complaints coming in, things other people don't want to do?
Well, it's funny. Like if you look at the different things that we offer, the usage is really correlated with how long ago we released them, right? So I think there's other companies that try to say, hey, we have this ML platform and we do kind of everything under the sun. And we've kind of in contrast tried to do bite-sized pieces of the ML workflow and do them really well. And it really takes a while before something gets, really good that people want to use it. Like every month more people use our hyperparameter search. We launched that, 2 years ago. And I think it's a really great product now, but it's taken quite a lot of people using it to get the details right where it's really delightful. Like there's tons of open source, hyperparameter optimization things that are really great, and we're not trying to say we have any secret sauce. We just try to make it really easy. Like so easy that you would just do it, right? Because I think that's when a lot of people kind of know they should be doing it, but it's kind of a pain to set up. It feels kind of risky if you spend a lot of time on a hyperparameter optimization that ends up going haywire. And so we try to make that really good. And then the next thing that we launched was our dataset versioning called Artifacts, and that is probably the number 3 thing that people use. And again, that's another kind of slow build where people want to version data sets. It's kind of painful. I mean, even just keeping track of the size of data sets that we get from customers now, like even the file that's just the list of the files that a customer has, gets so big that like syncing that without slowing down training takes a fair amount of work on our end. And so, our adoption curve on everything has kind of been as we've launched it. And we've released the model registry product, a couple months ago, and that has, like tens of excited companies using it. That might be a little more corporate. I don't know if, researchers would need to use a model registry as much as companies. So that may never have the same kind of volume of usage, but, it's earlier and we're still getting lots of feedback and still kind of actively trying to improve it. And then, we have a whole bunch of stuff in the works for 2023 that we're really excited about.
Anything you can share?
Yeah, totally. And again, it's nothing shocking because this is kind of push from our customers. We're putting out a thing called Weave that is really around allowing much more customization on our customers' end. Like, one of the things that everybody runs into once they become heavy users is they want to make their own crazy graphs. And, ML people want all kinds of crazy analysis and graphs. And we want to make it possible to not have to dump data out of weights and biases as much, and use the fact that your data is in a good database and kind of pull out the kinds of queries that people want and allow a lot more customization. So we're excited about that. We're also coming out with a kind of evaluation in production system that people have been asking us for years, but we really wanted to get that good. And a whole bunch of other kind of stuff around the ML workflow. There's a new product that we launched recently, but we haven't made a ton of noise about, called Launch, that I'm really excited about, which actually lets you launch runs from inside the weights and biases interface. And that's been surprisingly popular. So I think we're going to invest a lot more into that and make it really a great experience for everyone.
A lot of interesting things you bring up there. When I think about hyperparameter sweeps, it used to be kind of a research area that was pretty active. Bayesian optimization for hyperparameter optimization, then papers about, just, random sampling across all the axes is actually more efficient than literally sweeping. You'll get better coverage somehow in the right spots. I'm curious, can you share what's happening for the weights and biases hyperparameter optimization?
Yeah, so my observation was, I think it's pretty clear that if you're looking for the best set of hyperparameters, Bayesian optimization works well. And I think it actually works even better in production than in the papers. Like, the papers tend to use MNIST, where it's a pretty constrained set of bounds that are kind of reasonable guesses. And I think in the real world, people have less good priors on what good hyperparameters are going to be, and often many more hyperparameters that they could be changing. Yeah, but what we observed is when we would go into companies full of smart people, they were never doing Bayesian optimization, almost never. And, we asked them why, and it felt like the sort of open source projects felt like they were too hard to set up and too tweaky, right? Like, there's just so many parameters that you don't really know what they do, and you're kind of worried that the cost of a bad hyperparameter optimization would be really high. And then, Google had, I think, like AutoML, and there's some totally automated black box ones, but that makes people nervous because it's like, well, could we, reproduce this? Like, what is it actually really doing? And so we thought, let's just make something easy and transparent. So we implemented, Bayesian optimization with, Gaussian priors and also TPE for the modeling, and put in reasonable defaults. And then, we worked with customers to even figure out what are kind of better, reasonable defaults for kind of real world situations that you actually get into, because these papers are really run on toy examples. So I think they end up with kind of bad defaults for real world cases. And our idea was, look, we'll let you tweak whatever you want, but we'll start with reasonable defaults that'll usually get you into a reasonable place. And then, tell us if there's a problem, and we can kind of like handle that. And, there's some other details too, like if you run your search in parallel, I mean, a lot of papers gloss over this. Like, if you're actually running things in parallel, which you're almost always doing, and you run the algorithm like 10 times in parallel, it's going to come up with the same 10 parameters. So that's something that you have to deal with. And of course, there's papers that talk about how to do that in a clever way, but nobody really implemented that. So again, it was just like kind of cleaning up the real world details so that people would actually do hyperparameter search, because it's a pretty big benefit, right? It's like 2x, 3x, 4x speed up on getting to the same quality of accuracy or loss, or whatever you care about.
Absolutely. And I'll be honest, hyperparameter search has always intrigued me. And one of the things that has also intrigued me, I'm curious if that's part of what you do or not, is this notion that you could cut runs short.
Yeah.
So
so we do that too. Actually, it's I think people should use it a lot more, but the problem is that you don't learn as much if you don't let all the runs end. So it makes it kind of complicated to do the post-hoc analysis. But if you really want to get the best run, actually early stopping is much more important than Bayesian optimization or any fancy hyperparameter search strategy. So again, we implemented a paper. It's pretty simple, right? You let the runs run, and then you cut off the ones pretty aggressively that don't look like they're doing well after a certain amount of time. And, we tried to make that really easy to use. I think we really implemented the paper kind of verbatim. Hyperband, we could put a link to it. It seemed like the state of the art. But I think it's a little bit opaque. Like, it's a little bit hard to understand. The parameters are all like Greek letters, and we could probably do a better job of just explaining exactly what it is and what we're doing to our users. And I bet they would use it more.
Talking about explaining things, one of the things I noticed when doing my research ahead of our conversation here is you have a blog, but it became a little inactive lately.
Yeah.
In the last couple of years, actually. The things you just described seems like they would make for beautiful blog posts.
That's good feedback. Yeah, no, I think I've been. It's so hard to get in that maker mindset, or even writing stuff when you're running a company. I don't know how you do it with so many companies and teaching, but I wish I had more time to sit down and write.
Yeah, you need a lot of help, I guess, which I'm sure you have, but you need even more help. The other thing that stood out among the things you mentioned is model registry. It really stood out to me because I've never heard it before. I don't know what it is.
You're a professor. I think that's... So here's the basic problem, and it's really real. Like our customers talk about this a lot, right? When you're actually deploying, real stuff into the real world, you really want a record of what you deployed, and you often want some specific process about how things get deployed, where something gets put, as like kind of pre-production, a certain suite of tests get run on it, and then maybe it automatically gets pushed into production, or maybe somebody pushes a button, and then you actually keep track of when stuff goes in to production, which is, can be really important for like triaging things later. And a lot of regulated industries like automotive, you need to produce exactly the version of your model that was, running in a car, or running in a machine at a particular moment. So again, it's like not the most, complicated, like researchy problem, but, really getting it right where a whole team will use it and actually like want to use it, is the real challenge there. There's another thing too with some of the laws, especially coming out of Europe, right? Like you might need to remove like 3 examples from your training data of like 1 billion examples because 3 people requested it, and then really prove that like on this date, the model that's in production wasn't trained on the specific data. And it's like, again, not like intellectually stimulating, but a pretty complicated thing to do when a whole team is kind of working on this thing and running fast. So those are the kinds of problems that our model registry solves.
So far in our conversation, actually, everything you've said reminds me of something else you said earlier in a previous podcast that you were on. You said our true north is listening to customers, which is very intriguing because most companies' true north is their own vision, right? This is how things should be. This is what we're going to build. It's the right way. And you're explicitly actually phrasing it very differently.
Uh-huh. And I don't know, I think my CTO might get mad at me. I mean, he is like very opinionated, but I think it's important. It's important to us to really be listening carefully to customers. And I do feel like a lot of entrepreneurs get in a little bit of the Steve Jobs mode of like, I know what's best. And like that thing of like, a customer when like the Henry Ford thing, customer would ask for a faster horse versus a car. But it's like, if you showed a customer a car, they'd be pretty excited about it, I bet, right? And so, it's like, I think like true listening to customers isn't just about like, hey, what do you want? It's about like collaborating with them and like showing them ideas and really learning like how they're thinking. And I think one thing that really permeates Weights and Biases that's been responsible for most of our success is we've really taken a point of view of, it's the people doing ML that we love, that we care about, and we really want to collaborate with them. I think other companies develop too much of a point of view about exactly how, something should work. And in ML, the best practices are changing so fast. I think you need more flexibility maybe than in other industries. So, if somebody wants to use our thing in a different way than we exactly intended, or they want to, rip out part of our stuff and use their own crazy hyperparameter search thing, we love that, right? We're not trying to lock people into our set of stuff. We're trying to figure out what's actually useful.
One of the other things that I think must be happening as, Weights and Biases is the go-to tooling for tracking experiments is that from your end, you can probably spot trends much earlier than many other people could, because you would see practitioners start running different kinds of experiments, different types of data, different types of maybe real-world problems that nobody yet nodes are being tackled with machine learning, and all of a sudden you're like, wait, what's going on here? Do you have any such stories? I mean, I know some things might not be shareable, but anything you're able to share?
Well, the big thing that we keep seeing that's really obvious in our data is new frameworks. Like I feel like there was a time when we started, TensorFlow was clearly the incumbent, and people were using PyTorch, but they felt kind of bad about it. Like especially companies would be like, well, we're using PyTorch because we kind of like it, but we're going to switch to TensorFlow when we go into production. And then when we looked at our own data, it was like, man, like everyone is using PyTorch, like hardly anyone is using TensorFlow. And then we saw Lightning take off. And so we integrated, with them right away, but we were just like, wow, that's like a big trend. So like one thing for us is like, we look to that data to decide, who to integrate with. And so that's kind of a simple thing. We've been trying to kind of find, more interesting patterns to help the community. Like we tweeted out the average learning rate, which I thought was kind of fun. Like people were really into it. And then someone asked, what's the top random number seeds? And so we got a list of those. I don't want our users and customers to feel like we're like minding their private stuff to, like we really want to be like careful with our customers' data. But if there are ways to help the community with like, suggesting hyperparameters or like backtesting, hyperparameter optimization algorithms, I think those could be really great things to do, and we're starting to look at that.
One thing I'm curious about is in the kind of Twitter discussions about machine learning or go to conferences, all the talk is about very large models. Like that's the only thing literally pretty much anybody talks about. What do you see from a weights and biases perspective? Is that indeed what's happening on the ground at this point? Is almost all the training very large models, or is there still smaller models being trained?
No, I mean, I think that's a big disconnect. I mean, I love the large models. I mean, like if you look at our infrastructure bills, the large models totally dominate. But lots and lots of people use random forest. Lots of people are training on small data sets. I mean, the applications in research and the applications in industry are still quite different. And I think in industry, there's, much more care put into the size of the model and the, complexity of the model.
When you take a step back, independent of weights and bias specifically, and you think about what's been happening in AI over recent years, what do you think is going to happen next?
Well, you might know better than me. I have some bets on the market that I don't know if they're controversial, but they're sort of maybe different than, some of my investors think. I think that there is a real, I guess this is obvious, but there's a real explosion in applications happening right now. And I'm talking about like real world applications. Like, people ask like when, will deep learning, really be affecting businesses? And it's like today, like none of our customers, all of our customers are doing something that they're putting into production. And we work with almost everyone, right? I mean, we work with like a huge fraction of the Fortune 500 to do real things like developing drugs. That's a real application that people are really heavily investing in, factory automation, but even things like demand forecasting, which every business really needs. I mean, it is really happening right now. And I think the breakthroughs in, some of the stuff like these, like, Chat GPT, and Dolly, they kind of look like toys, I think, to like a lot of kind of business people. But of course, the applications of it are obvious. And I think that, we're about to see, I think that's going to fuel another explosion of use cases because suddenly a ton of more stuff really works. And then I think within companies, people think that, they still think that like there's going to be like 3 or 4 companies that just build models and everybody else like tweaks them. I mean, this is a lot of people in academia think it, a lot of people in industry think it. And it's just completely contrary to the data that we see, right? Like we see every one of our customers like hiring ML researchers as fast as they can. And we see them building really large teams to like integrate the models into what they're doing. And they want real ML engineers that, that do that. So I think it's like a really fast growing field. And I think that the ML engineers themselves in industry are going to be the ones that like push the innovation forward, right? So like I think you've seen how software engineers have so much power in organizations. Everybody talks about the rock star because they automate stuff. I mean, the ML engineers are sort of like automating the automation of software in a way. And so all the things that are true about software engineers, like, they're really like, they have like a lot of sway, like, companies are kind of coddling them, like paying them huge salaries. That's all happening even more extreme with the people that are working on ML. And I don't see why that trend wouldn't continue. I mean, you can imagine that everybody starts buying their models from OpenAI, but I'm honestly pretty skeptical of that story, even though I love OpenAI as a customer. I think you'd be surprised how much companies really, really, really want to develop their own IP and feel like they're holding their own models. And even if it's like fine tuning a model, they still want to hold that model. They still want experts to come in and do that. So I think like, ML is kind of overpromised, under-delivered for so long. And now finally it's like over-delivering. So I think we might even be underestimating the explosion of like useful applications that are about to happen.
Oh, that's really exciting. I will say, I mean, it's kind of hypothesis we had, meaning Richard Soker, myself, Chris Manning, Anthony Goblin, Suchi Sarai, when starting AIX Ventures, the kind of early stage venture firm for AI that we run, is that this is the time. There's going to be so many new, really, applications/industries emerging that weren't possible before, thanks to AI. And I really like what you said there, because I think it's very intriguing that as an AI engineer or machine learning engineer, you can, obviously, if you have a team, you can do more. But even on your own, if you are really good, you can get enormous things done, enormous accomplishments, which is really unique, I think, compared to most professions, how much you can even do as a single person in this field.
Yeah, I totally agree.
Now, one of the big trends, of course, is to do to use these large language models and hope that they'll do what you want them to do. And so one way to try to get that done is you fine-tune them on your own data and you hope then it adapts to what you need. The other way is to put prompts into these models that kind of effectively have some recency or / in-context learning effect on these models to do what you want them to do. It seems like from the things you described, that could almost be a weights and biases product too, essentially, rather than, data versioning tracking would be like prompt version tracking for every deployment. When was which prompt active for one query and so forth.
Yeah, no, we'd love to do it. I mean, we're practical people and we follow, what our customers want. So far, we haven't seen as much interest in prompt engineering from our like customers that are really working on stuff as you see on Twitter. But of course, sometimes Twitter is the leading indicator, and some of the results are truly amazing. So, as we see more demand, we might start investing in prompt engineering products. And we're starting to see customers kind of tweak our own product to do prompt engineering. I think what's for sure is that if you're in ML selling tools or a platform, you have to keep them super flexible because best practices feel like they change every couple months. And so we've really tried to keep, our technical debt low and our platform flexibility high to be ready for all the changes that we expect in the industry.
Now, one of the most interesting things to me about you, Lukas, is the fact that you started a machine learning company before that was really a thing. Back in 2007, machine learning companies were not really a thing. And I'm really curious, how did you somehow conclude that that's what you're going to do well ahead of the trends? Because I remember we were both students at Stanford, both having a good time working on machine learning research in the Stanford AI lab. I continued to do research, became professor, and so forth. You went a very different path. What made you go that different path?
Well, I think honestly, I actually had kind of a struggle in that lab working with Daphne, where she asked me to work on natural language processing. And I think that she didn't know at the time the data sets that well. So I was kind of taking her models and applying them to NLP. And a lot of it was topic modeling. And I spent months, I mean, I felt like a year working on WordNet. I don't know if anyone remembers this. And there was like there was this corpus of where every word would be kind of labeled with the sense that it was. Like, you know, is it like plant in the sense of power plant or plant in the sense of like living thing? And I was doing this topic modeling and I was really excited to get a paper out, and it seemed like it was working really well. And this is back with like Bayes nets, you know, and so they're really hard to get right. And I had like written all this software, and it's like all these nights where I was like, you know, not sleeping to get it done. And I was like, okay, we got this great result. And then I realized that like the topics were in like sets of 10. So it was like thinking like document 1 through 10 is a topic and like 11 through 20 is a topic. And I started like digging in more into the data, and the topics were actually the person that was annotating. And it was just like heartbreaking because it was like all this work that I put in that I thought was working. It wasn't actually figuring out topics. It was like figuring out the annotator. And it felt like a really uninteresting result that you couldn't publish. And then I talked to people that kind of knew that data set better. And they're like, oh yeah, of course. Like everybody knows that, like there's like annotator bias here. And I was just like, man, you know, and then I started working on, with Daphne and kind of other applications, like what else could we apply this to? And it just felt like the applications were totally based around weird things where you happen to get a data set. Like there was that Enron email corpus because like the Enron emails got subpoenaed. And it just felt like, wouldn't the more interesting thing be to collect data sets on meaningful applications and get them labeled and then use sort of normal methods, you know, the state-of-the-art ML methods that aren't that complicated at the time, to get useful applications. So, you know, I went in and, you know, worked at some startups, but that was really kind of nagging at me. And then when Mechanical Turk came out, I thought, wow, this is like awesome. Like we can finally label stuff. But of course, Mechanical Turk was so unbelievably hard to use. I really wanted to make a version that was just useful for labeling, because it really felt like at the time that was really the bottleneck in machine learning. And I had no idea how hard it would be. I think I just like, I don't know, just it seemed like a useful thing that people would want, and I had no idea what I was getting myself into.
And so then you founded Crowdflower, which was, as I understand, exactly focused on that, on helping people build their data sets, get them annotated.
Yeah. Yeah.
But this was long before deep learning took off, long before people were in such a large data set mindset, right? But somehow you knew or predicted, I don't know if you knew, but you predicted this is a really important trend.
Well, it was so obvious at the time, right? Because it was like that. I mean, Peter Norvig had that paper, The Unreasonable Effectiveness of Data, whereas like all the machine learning applications that work are the ones where we happen to have a lot of data. And so I wasn't the only one observing it. Like, I think it was just like unbelievably clear. But I think that the people working in machine learning didn't feel empowered to get their own data sets. And so they would just use whatever data sets got invented. I mean, even back then, I feel like the linguists really controlled the data sets that were created. So I felt like they put way more like process around the labeling than was really necessary, versus like getting a high volume. They're like, we should get like a smaller amount of high quality data, you know, which makes sense if what you're interested in is actually the linguistic result. But if you're trying to make like an application, you know, you might be willing to, you know, sacrifice like some of the annotation pieces to collect data at high volume for sure, you know, depending on the application. And so, yeah, I feel really proud. I mean, we helped a lot of companies actually deploy machine learning models, you know, back then. It was a meaningful thing. It was just a tough, you know, business to run, because you had all these, you know, human annotators around the world that you had to, you know, manage well. And that ended up being like a real challenge for me.
I remember, and I'm hoping I'm remembering this correctly, at some point driving on the 101, and I see a big billboard that says Crowdflower. And to me, that was one of the moments, I forget what year it was, it's many years ago now, obviously. It was like, wait, there's actually somebody out there making money with machine learning things? Can afford a billboard?
Wow, interesting. I feel proud that you felt that way. We had a lot of debate around the getting a billboard, but we've heard so many stories, and even like customers that came because they saw the billboard. So it turned out to be, ironically, a really good piece of marketing that I was honestly against because it seemed so expensive at the time.
It was the moment when I was like, wait, isn't that Lucas's company? There, this is actually working apparently. If we go a bit further back, I'm really curious. As a kid, what kept you busy, and how do you go from, most kids don't immediately think about AI as a career, I imagine. How do you end up where you are today?
Well, honestly, my dad actually had a huge impact on me by reading that book Gödel, Escher, Bach when I was like way too young, which has so many wrong ideas about machine learning, but I think it really sparked my imagination around how cool it would be if like machines could write their own programs and run them. And then when I was a teenager, I got really interested in this game, Go. And I really liked it because it was so elegant, and I was really good at it, which felt good. But then I kept thinking about how you would build like an algorithm to play Go, and the ones that would win at chess like really wouldn't work for Go. And so I was really thinking about that, like when I got to Stanford and really wanted to work on it. And then it was funny because it was like right in the, what do they call it, the AI winter, when everyone's like, don't do this, like, and so it really got discouraged in my first couple of years and ended up doing my undergrad in math. But I kind of wish I had done it in more CS and kind of gotten a head start there.
Well, I'm sure you more than made up for it since then. Now, it's interesting that games play such a big role, because if I think about myself, to me, that was the first time I got really intrigued by AI was when in one of the classes back in Belgium still, they started explaining how you would build a chess player, an AI chess player. And to me, just what seemed so intriguing was the fact that you could write code, and it was more hard-coded back then in the way they taught it than the way it's more learned, of course, today. But that you could write code that actually could then outsmart you.
Yeah.
That to me was one of the most intriguing concepts out there.
Daphne Kohler actually had this class that I took as an undergrad in AI. And the best part of the class was we wrote a reinforcement learning algorithm to play Othello. And it was just so fun because you would watch the Othello program, start, and it's so bad, and then it gets better and better, and then it completely crushes you. And the actual score isn't obvious how you should do it in Othello. And I remember just watching the program learn and getting better and better. And it was honestly one of the peak experiences of my life. It's such a great contained project. I hope she still does that that class project. I think honestly that's what really made me wanted to research in AI.
Now, one of the things that makes you stand out compared to most researchers, of course, though it's changing now, and I think there's a whole, big entrepreneurship push all across AI, is you're early kind of taking on entrepreneurship in this space. And I'm curious, one thing is the vision of data and so forth. Better data will lead to better results, but there's a lot more to the vision than to running a company than just the vision you come in with, right? So I'm curious if you have any advice for people who are thinking of starting their own companies, things, maybe lessons you've learned, or maybe things you just knew ahead of time and, are proud that you got right.
Well, I got a lot wrong. I mean, I think, Crowdflower took many, many years before it started to take off. And now, Scale AI is so much more successful, which still kind of eats at me as an entrepreneur. But it's a good question. I mean, I think that one thing I kind of worry about a little bit for this is absolutely not true when I was starting Crowdflower is I feel like the first part of raising money has gotten really easy for people, coming out of your lab. And I think it kind of tricks people in a way. When I was trying to raise money for Crowdflower in 2007, people really advised me, don't talk about ML. That sounds like a bad thing to bring up. It sounds like a science experiment, don't say it. And it took us years to raise our first round. I mean, we had to get revenue before that, and we had no money. I mean, I remember, biking over to Best Buy to buy a fax machine to like send our first contract. And I think it gave us a kind of resilience or toughness that I think is really important at some point, as you know, from the companies that you've done. But I think that people maybe get the wrong impression when, they can raise these big rounds like right off the bat and just sort of spend money for a while. Like, at the end of the day, you have to build a working business. Like all the successful companies have built a working business. And I don't think people luck into it as much as people imagine. Like, maybe Google discovered this incredible money fountain, but I remember talking to, Larry and Sergey when they were really young, and they were pretty focused on making a working business, I think more than people realize. And advertising and search was always on their minds, and kind of figuring out how to do that in a smart bidding way, was a real focus on monetization that I think maybe people don't have enough of. Like when I look at the other ML companies in our space, I think you can instantly tell there's like two genres. There's like one started by business people where the product's not that good. and there's one started by ML people, which typically is like, hey, we're giving this away for free and we're going to kind of monetize with some other product that we're going to launch later. And I think both of those paths are really risky in this industry.
Yeah, I mean, that definitely resonates. I mean, it's tricky, of course, because kind of self-enforcing that you will not raise much and be very scrappy, while it might have some benefits if you have competitors who are better funded and somehow still are scrappy, and despite being well funded.
I would say take the money. Like I'm not, I'm just saying I think that there's a lot of benefits to raising a lot of money for sure. But I do think there's this kind of hidden downside that in some ways makes things tougher for people building companies today.
Yeah, I mean, that absolutely resonates. And there's this whole craze, of course, now where in generative AI, where it,
yeah,
just people raise $100 million out of the gate.
And then they fight me on like $100 license for weights and biases, and it's like, I'm gonna kill you. If anyone who's out there is listening, if you've raised $100 million, you can pay our full price for for a weights and biases license.
Now, not exactly an AI question, but we're both parents. In fact, you've been parent a little longer than I have been, so I'm actually curious. What are some things you prioritize for your daughter?
That's a good question. I really want her to experience as many different things as possible. I think that's a big priority for me. Like I love to just kind of push her a little bit to like explore the world that we're in. I also want to have a really good relationship with her, and so I think I try to follow her interests as much as possible. Like I feel like my dad did a really good job getting me interested in math, not by like beating it down my throat, but by genuinely being really interested in it. And so, I don't know, my daughter right now, she's 3 and she is really, really interested in storytelling. And I just love to let her like tell me these crazy stories. And then, I try to write them down for her. And, it just makes me so happy that she's just so into something. I guess I don't have a very set philosophy. I'm still figuring it out. I go back and forth. I don't know if you feel this way yet, but like how much to kind of push her to do stuff. I mean, sometimes I feel like, why am I sort of inflicting my own worldview? But then sometimes she really likes it. And so I often feel conflicted about that.
Yeah, I think it's complicated. I mean, ours are still below 1 year old. So
is your child still only 1? Wow.
Not even one. Not even one. Wow. So yeah.
I see.
Still much younger. So, but it is interesting because when I think back to my own childhood, I feel like sometimes my parents did, I would say, strongly nudge, strongly encourage, never truly force, but strongly encourage me to at least try certain things. Always with the notion that, just try it once, don't like it, don't have to go the next time, but just go try it out and let's see how it goes. And I feel like usually as a kid I was right. If I wasn't excited, then the one time I tried it, it was just, not that great. But then there are these exceptions. And when I look back, where mostly things in my experience where I was nudged to go do something that I actually wanted to do, but I was afraid to do it because none of my friends were going to do it, and I would be alone, exposed to a whole new group of people and not knowing anybody going in. And I think that's a place where my parents definitely nudged me to, you want to do this, don't hopefully, you'll meet somebody there you can get along with in this camp or this event or whatever. And I think those are the ones that definitely were very good nudges.
I feel like I could still use that nudge sometimes.
Yeah. It's interesting, but it's also interesting because in the age of AI, it seems like everything's changing so fast. And it seems like if I even think about what job are my sons going to do, it's just like, I don't even know what jobs that are going to exist 20 years from now, which I think if you go 30, 40 years back, it was probably much easier to think about which jobs would exist in the future and think ahead towards those jobs.
Oh, that's funny. Like my wife's parents, I feel like were much more like they were like first generation immigrants and much more like, okay, be a doctor or a lawyer. And then when my wife became an entrepreneur, they were kind of irritated by that, I think, or felt like failures. But that actually turned out to be an incredibly good move for her. So I feel like there's quite a lot of uncertainty, like you say. And it's funny, my wife is already saying, hey, like, why don't you teach Matilda to write code? And I'm kind of looking at the code auto generation tools out there, and I'm like, I think writing code is really fun. Like, I'm happy to do this for fun because I love it. But I don't know if this is a really good life skill that we're teaching her. It might be like learning to like weave or something.
Learning to play Go or chess.
Yeah, exactly.
Good brain training, but it's maybe not a sustainable occupation in the long run.
Totally.
Yeah, very, very, very interesting. If you think specifically about, let's say, high school students who are much closer to making career choices, right? Are there some resources, if they're interested in AI, that you think are really good resources to go check out?
Yeah, I feel like there's an incredible amount of resources, and it sort of depends on your interest. Like, I feel like I met a 19-year-old a couple days ago that like learned to code from YouTube, and now is training these a huge LLM. And so I feel like if you're technical, there's just a massive amount of online learning content on whatever you care about. I feel like the light intros that are really fun is like the 2 minutes paper channel, like this channel. I feel like it really just depends on what you're into, but I can't believe the amount of interesting free resources. Like, I've gotten obsessed. I don't know about you, but I kind of couldn't believe when 3 Blue, 1 Brown came out how well done all this math stuff was. And I have an undergraduate degree in math from Stanford. I feel like I know math pretty well. And his stuff was still like challenging me, and it's kind of gotten me down this rabbit hole of like math YouTube that I feel like I still learn from. So I don't even know we're recording this now, but I feel like there's just an explosion of awesome educational stuff on any topic.
Yeah, I think that's definitely, it's amazing what's out there in terms of the community. The machine learning community is just somehow very oriented towards putting materials out. A lot of people take a lot of joy in sharing their expertise and try to find the best possible way to share that expertise in a large scale way. You have put some course materials out yourself. Are you still actively doing that these days?
We are, yeah. The main way that people find weights and biases these days is actually a really cool program that we have where people can publish little reports on any topic. I say little, they could be big, but they tend to be a little more lightweight than a research paper and doesn't have the same, vetting process where it has to be, it could be just like, how do you use PyEnv well with machine learning projects, or like, how should I set my learning rate if I'm doing like a vision application, or, how do I get started in Hugging Face? And so these reports are actually the main way that people discover weights and biases. More people come to read the reports than to use our tool. And I feel really proud of that because I feel like we're doing marketing, but we're putting a lot of good into the world, like useful stuff that is actually really hard for me even to figure out. Like setting up a machine and getting the GPU running is still, a challenge for me. And then we have these longer classes, which you also make available for free, like an MLOps class. I mean, I feel like there's so much really good stuff on training models. Like so much university content is out there for free now that we don't necessarily want to compete with that. But I kind of feel like the stuff that we know really well is like how to make the stuff work in production. So I feel really proud of our MLOps course, and it's free for anyone that wants to take it. And it's been so successful. We actually plan to put out more. Again, the topic's kind of guided by what people ask us for.
Well, I think it's super exciting you're putting that all out, and I want to make sure that we'll sync up later and make sure to include a link in the table of contents, because I think it's just such a great resource for people who want to learn more, especially on the practical side, get things going. Maybe one final question, Lukas. If you think about the future of AI, what's gonna, what might be happening in the next 5 to 10 years? What are some of the things that you are personally most excited about?
I mean, one thing that I don't understand as well as I should, but seems really exciting is the biology and chemistry applications. Like we're seeing more and more people using weights and biases to develop drugs and develop new materials. We see a lot of chemists actually coming in as users of our platform. And I think we work with almost all of the big pharmaceutical companies now, which like they didn't have any ML program a few years ago, and now they buy hundreds of licenses for their teams. And
wow,
I'm so excited about that because it feels so meaningful. Like, like making a new drug that actually saves lives, I think is just, such something that I think the whole industry should feel really proud of. And then I kind of think, again, like I was saying, in my head, I feel like Transformers pushes things for a good long time. Like it doesn't really show signs of running out of steam from my perspective. So I don't know about AGI and all that, but what I do know is that there's like a rich vein of like a lot of things working better and better and better. And actually, like if you look at like, I was thinking about this, like you look at like speech recognition, right? People have been working on speech recognition for the last like 30, 40 years. And if you plot the state of the art, there's not really a step function change anywhere, right? It just sort of improves, steadily over time. But then there's this moment where speech recognition isn't annoying anymore, and you're kind of happy to talk to, an Alexa or something. And I kind of think that's going to happen with a lot of other stuff too, where we might like chat interfaces to every product, right? You're starting to see that. And those have been so annoying for so long. But you know what? Like maybe it's time to revisit that. Like maybe I don't want to query my database with SQL. Maybe I want to query my database with chat, right? And the code generation right at this moment, just that seems like in a way the most exciting thing because that accelerates the whole industry. And I don't quite find the code generation stuff now like really useful day to day, but it is like so close. And I imagine it's only going to get better and better. And so that just feels like something that'll kind of touch the whole industry and accelerate everything.
Yeah, those absolutely resonate. And just kind of, not sure if you would remember this, but Microsoft used to have this thing called Clip, the most annoying little assistant ever. I wonder if Microsoft and OpenAI will makes me wonder if Microsoft and OpenAI will go retro and
bring that paperclip at the eyes back. That'd be a bold move. I feel like people still hate that thing like 30 years later.
That was the boldest move ever. Yes.
I feel like the one really like missing thing is like household robots. So I hope that you give me a robot in my house at some point. That's.
Hey, I'd love to make that happen. I think it's a very hard problem because of the diversity across homes. There's very little structure, and the physical world is very unforgiving compared to the digital world. Usually, AI makes a mistake, you just fix it by typing something else instead. Physical can make a big mess, but it's something I'm dreaming of to hopefully get there.
Who would have thought though that like writing code would be easier than like a little robot that runs around my house and helps me out? I wouldn't have predicted that 20 years ago for sure.
Yeah, I wouldn't have thought that either. Writing code seems such a sophisticated practice, and then it turns out once you've seen enough statistics of how to write code, you can get going as an AI.
Yeah.
Well, Lukas, this was a lot of fun, really insightful. Thanks so much for making the time.
Yeah, thank you.